Number system problem solving. First question from number system classification. Every integer is a rational number. True or false? So every integer like 2 can be represented as 2 by 1, which is like p by q, the standard form of number system, and q, that is 1, is not equal to 0. Hence 2 is a rational number. So every integer can be represented as a rational number. P is integer, q is not equal to 0 and also integer. So every integer is a rational number. That is true. 5 by 1. Numerator p 5 is an integer. Denominator 1 is an integer. P by q, that is 5 by 1, is integer by integer. And q is not equal to 0. Hence 5 is also a rational number. All integers are rational numbers. Now every rational number is an integer. True, false? We'll take example. Take one rational number like, so basically the question is the reverse of first statement true or not? Every integer is a rational number, so is every rational number an integer? Let's check. 5 by 7 is a rational number but not an integer. It's not integer. Hence every rational number is an integer is a false statement. But 16 by 2 is a rational number and it's an integer also. So it is true. So sometimes some rational number are integer but not always. False. Next question. So how many rational numbers can be found between any two rational numbers? Any two rational numbers. So we know that if one number is p, another number is q, then one number in between them is p plus q by 2. And that will be an integer. So suppose two rational numbers q1 and q2 are there. So in between we can have how many rational numbers? So q1 plus q2 by 2 will be a rational number between q1 and q2. I will repeat again. Q1 plus q2 divided by 2. Suppose that is, let's call it q3. So q3 is always in between q1 and q2. Hence we can say that at least one rational number is there between any two rational number. That is q1 plus q2 by 2. We call it q3. So one statement is there, between any two rational number there is always one rational number, that is summation divided by 2, q3. Now q3 is again a rational number because summation of two rational numbers is always a rational number. So between q1 and q2, q3 is there. Now between q3 and q2 also there will be a number, that is q3 plus q2 by 2. We call it q4. So q3 is also a rational number, and we have seen that between any two rational number there will be another rational number. So q4 is between q3 and q2. Similarly q5 will be between q1 and q3. That is q5. Hence so on, between q1 and q5 another rational number will be there. So between any two rational number infinite rational numbers can come. So answer will be infinite. Next, how many rational numbers can be found between any two irrational number? Irrational number we will see later on, but the answer will be infinite. How many irrational numbers can be found between any two rational numbers? So irrational number we will read. So, but I am saying that again answer will be infinite. You can do further study. Otherwise, in subsequent video we will discuss about this. So these kind of questions, objective questions, can come on number system, and these kind of questions you will find in IIT, JEE, many competitive examination of 12th also. Very easy concept, but we ignored these concepts. So how many rational numbers can be found between two integers? It depends. So suppose integers are 5 and 6, then in between infinite numbers are there. Next question is, how many integers can be found between any two rational number? Question 3 and 7 are linked. You can read properly, you will find it. Question 3 and 7 are linked because integers are also rational number. Now question number 8. Two rational numbers, 1 by 2 and 10,001 divided by 2. These two are rational numbers. In between them we can find many integers, 1, 2, 3, 5, 10, like that. $5,000. So in between these two rational numbers we can find many integers, but between two, like half and 3 by 4, half and 3 by 4. So half is 0.5 and 3 by 4 is 0.75. Between these two rational numbers there is no integer. So it depends, can't say how many integers can be found between any two rational numbers. It depends on the rational numbers values. 0.5, 0.75, and that is 1 and 2. So no rational number in between them. 1 by 2 and 3 by 4, no rational number. No rational number. So between 1 by 2 and 3 by 4 there is no integer. There is no integer. Question is how many integers? So we can't say. Depends. How big are those rational numbers? Now, rational number equivalent form. We have seen the equivalent form. The question is find 3 equivalent rational numbers for the following numbers. So equivalent form is x by y is a rational number. Then you multiply k to the x and k to the y. Those are equivalent rational numbers. Similarly, you divide k to x and similarly divide k to y, that is rational number. So equivalent, to make something equivalent, you multiply or divide by same numbers. We will see examples. 1 by 7. So find 3 equivalent rational numbers for 1 by 7. We'll do 1 by 7, multiply 1 times 5, similarly 7 times 5, it becomes 5 by 35. Similarly 1 by 7, we can multiply 9 to the numerator and 9 to the denominator. It becomes 9 by 63. Equivalent rational number. 1 by 7 multiply to the top minus 4, bottom also minus 4, same number. We need to multiply same number. That becomes minus 4 by minus 28. Remember, we should not multiply by 0 to the denominator and numerator, because denominator can't be 0. Similarly for 10 by 9, you need to find, multiply something to the top, same thing to the bottom, but not 0. 50 by 45, so equivalent rational number. Similarly 10 by 9 multiply by to the top by 3, bottom by 3, 30 by 27. Ten by 9 multiply by 10 to the top, similar thing to the bottom. 8, so 8 can be written as 8 by 1. 8 times 5 divided by 1 times 5, 40 by 5. 8 times 2 divided by 1 by 2, 16 by 2. Similarly, we can divide also. We can divide by similar number and make equivalent rational number also. Next is minus 5. So we need to find the equivalent rational number. Minus 5 times 2 divided by 1 times 2. So this becomes minus 10 by 2. So equivalent rational number minus 10 by 2. Next topic is coprime numbers. We will practice. So we need to check whether these two numbers are coprime. So how we will check coprime? First write all the factors. Factors means in which integers table, multiplication table, these numbers come. So 10 comes in 1's table, 2 tables, 5 tables, 10 table. 6 comes in 1's table, 2 table, 3 table. 1 is common between these two. 2 is common between these two. So more than one number is common, hence 10 and 6 are not coprime numbers. Twenty-one and 10. 1, 3, 7, 21. 1, 2, 5 and 10. So common is only 1, nothing else. Hence 21 and 10 are coprime numbers. So while checking for coprime, we should check factors. What are the factors? 10 and 9. Obviously these are coprime. 1 and 7. Obviously these are coprime. Now 10. In 10, 1, 2, 5 are there. And 10 factors. 9, 1, 3, 9. So only 1 is common. Hence 10 and 9 are coprime numbers. Here 2 numbers means you need to check between numerator and denominator. I should have written like check whether denominator and numerator are coprime. So 10 and 9 are coprime numbers. 2 numbers means between numerator and denominator. Wrong way to represent. Please excuse me. So 1 is numerator, 7 is denominator. 10 is numerator, 9 is denominator. I had to check between numerator and denominator whether 2 numbers are coprime or not. If coprime, it means rational number is in its simplest form, simplest equivalent form. 8. So 8 is a rational number. We can write as 8 by 1. Eight, 1, 2, 4, 8. 1 is simply 1. Now rational numbers simplest form. Are these rational numbers in their simplest form? So 12 and 42. We will factorize them. We will write there all the factors. So 12 can be written as 1, factors are 1, 2, 3, 4, 6 and 12. 42 factors are 1, 2, 3, 6, 7, 14 also, 21 also. 14 I missed. Okay. So 2, 3, more than 1 common factor. 1 is already there. So these two are not co-prime numbers. Hence, if numerator and denominator are not co-prime numbers, it means the rational number is not in its simplest form. We will see how we can convert these in simplest form. So these are very easy as per 10th class standard. But I am taking time so that you can understand. You can watch this video with increased speed. So 12 by 42. How we will simplify? Write the factors, cancel out the common one. Final answer is 2 by 7. And 2 by 7 is a simplest form. Two times 5, 3 times 3. So nothing is common between these 10 and 9 numbers. Hence no common factor. So number is in its simplest form. I took these problems. These are very easy to understand. But I took this so that nothing is there to be doubted. Everything is clear. Every small problem is being discussed with the help of examples. So 10 by 9, 10 and 9 are co-prime numbers. Hence their ratio, the rational number, will be in simplest form. 8 by 1. 8 is 2 into 2 into 2 divided by 1 into 1 into 1. Co-prime numbers. 8 and 1 are co-prime numbers. Hence 8 is in its simplest form. Very easy to understand. I have covered all kind of examples. So conclusion can be drawn that every integer is in its simplest form. It can't be simplified further. 25 by 15. We can see that 5 is a common factor. So 25 and 15 are not co-prime. We'll go step by step, but just by looking at the rational number, you can say that these are co-prime. So 25 can be written as 5 cross 5, 15 as 5 cross 3, 5 is common. Hence 25 by 15 is not in its simplest form. 5 by 3 is the simplest form. Now, interesting question 1. Obviously 1 can't be simplified further. 1 is in its simplest form. Conclusion is every integer is in its simplest form. Every integer is in its simplest form. So simplest form, very basic question. This kind of questions where you can find this on FitG, other coaching institutes tests. You can find these are the basic thing, number system. But very important to understand. Coprime. This is a very good concept to understand. Many difficult questions can be formulated based on this. But these are the simplest thing. Whether check whether numerator and denominator are coprime or not. If coprime, it means simplest form of rational number. So coprime. So 27 and 16, nothing is common, no common factor, hence coprime, simplest form.